guys, I'm going to do this really fast. I'm going to review for exit ticket number 7. We'll write in pink today. I'll just fill in that. Exit ticket 7 is tomorrow. So, you have to be able to calculate the effective nuclear charge. So, if you have to calculate how many electrons are shielding the valence electrons. So Li has 2 shells, 1, 2, and then a third electron in the third shell. So 2 electrons are shielding the valence electrons from filling that positive charge. Fluorine has 9 protons, so let's do that. So 9 protons means 9 electrons. 1, 2 in the first shell. 1, 2, 3, 5, 6, 7, 8, 9. So again, we still have 2 electrons shielding the valence electrons from filling that positive charge. So that's how many electrons are shielding. Okay? And then we just take that number and subtract it from the total protons it has, and that'll give us our effective nuclear charge. Okay? You need to know that if electron is in the first shell, that's what it's saying right here, and n equals 1, so the first shell, this is the nucleus, that little pink dot in the middle, in the first shell. If the electron's in here, that means that nothing is shielding it. So it fills the full positive charge of the nucleus. If the electron is in the second shell, that means that 4, 5, 6, 7, 8. That 2 electrons are shielding it from the positive charge. That first shell, which is 2 electrons, is shielding it from that positive charge. And then the third shell, n equals 3. We add up the second shell and the first shell. So 2 are in the first shell and 8 are in the second shell. So 2 plus 8 will give us 10 electrons are being shielded, are shielding the third shell's electrons from filling that positive charge. Okay? So once again, if we do electron n equals 1, we have 0 shielding, n equals 3, 10, and n equals 2 will be 2 electrons. Okay? So if you just remember that, you should be good to go for tomorrow. So n equals 2 is 2 electrons. N equals 1, 0 electrons shielded. And n equals 3, 10 electrons are shielding. Okay? That is our rule for shielding. Electron configurations of ions, remember, if you have a positive 2 charge, you take 2 electrons away. Negative 2 charge, meaning we're getting more negative, so we're going to add 2 electrons. So positive charges, we take away electrons. Negative charges, we add electrons. Okay, last but not least, you should be able to do the orbital notation. Okay, let me do an example and be able to see which one is more magnetic. So say we had 2p. Remember, there's 3 orbitals in p's. Okay? So this is a random atom. We'll call it atom A and atom B. Different atoms, okay? So say we had atom A have one of the orbitals filled. So we have 2 unpaired electrons, so they don't have a pair. Let's say atom B has all 3 unpaired. Totally butchering this. Electrons. So 2 versus 3. 3 is greater. 3 is more magnetic. Remember, the more unpaired you have, the more magnetic. Okay, that is it for the review. Good luck tomorrow on your exam.